Good day all. Today we're going to switch it up to the science side of mathematics, and we are going to discuss some of the equations of motions. Some students seem to struggle when using these equations due to the complexity of some of the equations and that they don't make sense of where they came from. But these equations are just derived from some everyday equations that we've already used in past classes. So before we start, let's go through all the variables in play. Okay, so first we have v, which will be final velocity in meters per second. We have u, which will be initial velocity in meters per second. We have s, which is displacement in meters. We have a, which is acceleration in meters per second squared. And then we have time in seconds. Okay, something important to remember here is that these first four equations here are vectors, meaning that you have to have direction, meaning that if it is accelerating, you give a plus sign before it. If it is decelerating, you have a minus sign. If it's going to the right at, 10 meters per second, then you say plus 10 meters per second. If it's going, then if it switches direction, goes left, you have to say it's now going minus meters per second. It's stuff like that, guys. You have to say what direction you are setting as your positive direction when working with vectors. But you guys will get more practice with that as you work on that throughout your time using science. Okay, so let's get started with this first equation here. Okay, v equals u plus at. So final velocity is equal to initial velocity plus acceleration times time. Seems simple enough, but how did they actually get this equation? How this was actually derived was from this equation here. A is equal to final velocity minus initial velocity over t. Okay, and I can see already some of you will know what to do from here. Is that you see it's just, from there it's just reorganizing the formula. So you get at is equal to v minus u. Okay, so acceleration times time is equal to final velocity minus initial velocity. Then all you do is you take that u to the other side, so the initial velocity to the other side, and then you get this original equation up here. V is equal to initial velocity plus acceleration times time. Right? Seems simple enough? Okay, for the next one. The next one actually uses something called a velocity time graph to work this one out. Okay, so when using, actually I'm going to erase everything that we've done so far. Okay, so it uses a velocity time graph. Okay. To do it. Some of you would have worked with these before, some of you wouldn't have. It's fine, I'm going to explain it now. And something important to know about the velocity time graph, let me just actually first draw in the line here. Okay, so something to know about the velocity time graph is that S is equal to the area under the graph. Okay, so that is equal to the area under the graph. Okay, so what they did is that they took a velocity time graph with initial velocity u, okay, going up to final velocity v, okay, and then they were like, okay, we need to work out what the displacement is. What is the area under the graph? Okay, so first they had this little rectangle down here. So as you can see, it goes from 0 to u and 0 to t on each side. So S is just equal to the area of the rectangle, which would be ut. Okay, then they needed to get the triangle up here. Okay, so they went plus. What's the area of a triangle? It's half times base times height. Okay, so what's the height here? Okay, and the height we can see is v minus u. So let's put that in here. V minus u, and once again the base is t. So we have is equal to ut plus half v minus u times t. But now this looks close to what we have up here, but it doesn't look like the final formula. But it's because, remember what we did earlier. Remember what we said AP was equal to. It equals to v minus u. So now all you do is you substitute that equation in there, and you get S is equal to ut plus half. Then AT goes in for v minus u, so, and then there's a t at the end, so it becomes AT, and then because of the t at the end, it becomes AT squared. So that's how you get the second equation. Okay. The next equation is a little bit more complicated, but still not really. What it does is that it starts with this initial equation here. It takes that one up there, okay? And then it squares both sides. And then you get, so let's put this in brackets, u plus a t, and then they square both sides. Then from that point on, you'll get v squared is equal to u squared plus 2uat, that's just from multiplication, plus a squared t squared. Okay, just simple, that's just multiplying the brackets out, it's very simple. Now what they did is that they decided, hey, we're going to take 2a out as a common factor here. So what they were is v squared is equal to u squared. They didn't take it out of the first term, but they took it out from this point on. Is e plus 2a, okay, then in the brackets you'll have ut plus, okay, then here, because there's no 2 at the front, we have to put a half here. Half, took the a out, so 1a stays there, so it's not a squared anymore. And then the t is still there, so it stays t squared. Okay. Once again, we seem very, very close to our original formula. But now, look how easy it is that equation 2, s is equal to ut plus half at squared. Look, that's the same as what's in this bottom bracket down here. So all you do is, instead of that bottom bracket, you substitute s, and you get v squared equals u squared plus 2a, okay, and then s, because you've substituted s in place of that whole long bracket down there. Okay, see, seems quite complicated, but actually very simple. We're just using the same formulas over and over again. Okay, let me just quickly erase that. Now the last equation is the easiest one that you guys will find. Okay, it just uses 2 equations to work it out. So we get displacements is equal to v bar, okay, and if you guys do statistics, you'll know what v bar should mean. And it uses the equation v bar is equal to half u plus v. Okay, so for the guys who don't know, okay, v bar is what is the symbol for average velocity. So that's why it is half u plus v, because it's taking the 2 velocities we have and dividing by 2. So finding the average of those 2 velocities. And literally, to get this last equation, it's so simple. All they do is that we have v bar in this equation over here, and we have what v bar is equal to over here. All they did is they substitute what v bar is equal to into this original equation. So they got s is equal to, so instead of v bar, we go half. Let's put 2, let me just try and make that a bit better. Half u plus v times t. And that's how they got the final equation. I hope this was of some help in helping you understand where some of these equations come from and how math and science work very closely together to find out some of the rules that we know today. Enjoyed this lesson, guys. I look forward to seeing you guys next week. Thank you.